Would you do number 8? Your life depends on it. You're on the side of the road, you're out of gas. They'll give you gas if you can solve number 8. What are you going to do?
It's fantastic.
Not too many. It's $100 each you're carrying. Know what I'm saying?
Oh, I got you.
$500 right there.
Now 400.
Good job. That's it. So we have our calculators. How are we going to? We're on the side of the road. We have our calculators with us. Good for you guys. I like that. What'd you do? Okay, so you broke it down. All right, so this is one way of doing this. You said 3 times 3 times x times x, 3 times 3, x, 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 x. You don't have to do it this way. There's a lot of ways of doing this. I see you erasing. So then what'd you do?
I pulled out the exact pairs. 3x times 3x squared to radical x.
And then what'd you end up with? 9x to the third. Right. Well, that's not working. Try it over here. There we go. 9x to the third, radical x. Okay. Well, leaving these 4 x's, we're pulling out pairs. Remember, these are under the radical still. Yeah. And then when we multiplied these together, that was 9x to the third. Okay, that's good. I like that. Other thing you could do if you wanted to is multiply those together right away and then simplify that. You'll get the same answer, and I'm not saying either way is better. I'm just showing you a different way of doing this. And then you'd have a pair of 3's, 3 pairs of x's, 9x to the third, radical x. Okay, so whatever works for you, there's probably about 7 ways you could skin this cat if you wanted to. But just as long as you're getting this answer, life's good. Any questions on that? All right, let's look at number 9. You choose your method. You can simplify and multiply or multiply and simplify. Doesn't matter. Go ahead, I'll let you do number 9, and then I'll try and catch up with you. Remember, these are cubed roots this time. Yeah.
Am I able to take this 5 and these 2 times for a 4 to 3, or?
Yes. So 5 will come out on that.
You'd have to have 3, like,
Right. Okay, so here's what I see now. Remember, I'm looking for groups of 3. These are cubes, so I see a 5, a Z, another Z, right? Because there's 6 of them all together. Maybe you want to write them together if that makes it easier for you. And then a Y. So I'm going to take out a 5, Y, Z squared. And then I'm left with the cubed root of 2 times x times 3. 6x squared. Do you agree with that? Silence a good thing here? Do you agree with that? Okay. Let's finish up through 13. Work on those together, help each other out, and have fun. Good morning.
Morning, I have
Thank you. Page pace will get you caught up. Do you know Paige? Good.
Would you add each other and like put 7 and then bring
No,
those- no.
multiply.
Oh,
It's all multiplication. Okay, so I started number 10 the way I would do it. I would multiply the 3 and the 4, and then multiply the radicals together. That's not the answer, because it needs to be simplified, but that's the first step that I would do. Yes. Yeah.
So since we're looking for pairs of 2, there's 2 pairs of 3s, and then 3 pairs of x's.
Right.
So then we put that in, so it's 3 times 3, no,
Yeah.
radical,
No radical yet, because you pulled out x's too. Wait, what is this? This 2. Those are all 2s? Oh, you got way too many 2s. You're going to get 16, right? So 2 times 2 times 2 times 2 is 16. And then I'd have x and x in there too. Oh, good, right. So you pull out a 2 and pull out another 2. Yes, but the art times this too. Okay, so now you multiply those together, and you get 9x to the 3rd. Radical x. Yeah, it's not under the radical anymore, because there is no radical, because everything paired up. Right, and that's what I have here. Perfect. How are we doing? Bad? Oh, good. Okay.
and then
But I didn't even get the 16x squared.
Well, that was under the radical, so I got 12x also.
Oh, alright, I see.
You're okay?
Yeah.
Yes. Well, remember you need groups of 3 this time. Oh, you did, right? Yeah. No, the negative 3 will come out. Yeah. Do you know what I mean? I'm not sure what you mean by canceling them out. No. If you were adding, they would. We're not adding, this is all multiplying.
What would you do with it? Would you group them together?
Yeah, it'd be a negative 3. You're going to plot that group of 3,
Okay.
and it's going to be a negative 3 that comes out.
Okay.
Okay, a lot of questions on the negative 3 on this one. You have a group of 3, you have 3 3s, but since one of them's negative, it's a negative 3 that's going to be coming out. Thank you. Can I give it back to you? Thank you. I see a group of 3 x's and I see a group of 3 y's. I'm sorry? You have to keep going because that will simplify when you break those down. You'll find pairs. For number 12, I still have 4y squared under the radical. Did you have that? Boom. Good job by you. Are you healthy? Good. How you doing up here? You doing okay? How you doing? Good. I'm sorry? Not too well? 13 you're on? I have this. Yeah, that's right. That's what I'm going to do now. That's where you're at right now. And so now we're going to look for pairs. So I got 3, x, y. And you're going to multiply that by 14. So 14 times 3, 42. X, y, that's going to be on the outside. And then 2xy off the inside. What you got? Awesome. How you doing? Have you ever done this before? No.
I do that, but not like this.
Okay. Well, if you're comfortable with what you're doing your way, it's
Yeah, it's nothing on the
good. Are we ready to move on? Anybody have any questions on these before we move on?
If we stay here for the next 3-4 days,
What's that?
do we stay here the next 3 days?
You like this better than the long division? 2 days. We're going to do this for today and tomorrow. Then we get into the factoring thing a lot more. Okay, there are a couple ways of doing the division problems. And sometimes it's easier just to divide the term out first and then simplify. But the point is you cannot have a radical in the denominator. Okay, can you remember that? You may not have a radical in the denominator. But this one, we can simply divide this out. 63 divided by 7. What's 63 divided by 7? Nobody grabbed a calculator. Good job by you guys. All right, so that's 9x, and then subtract the exponents, right? 3 minus 1 is 2, so you have radical 9xy squared. Yeah, now we get to simplify that, which is 3 times 3 times x times y times y. 3y times the square root of x. So sometimes they're going to divide out evenly, and it's going to be an easier question that way. Now, you do not have to show this step. I think some of you can do that right to there. And if you're one of those people that like to do that and are good at it, that's fantastic. If you need to write it out, no problem there either, as long as we get them right. Okay, so 15, we can do the same thing. 54 divided by 2, 27. X to the 5th divided by x squared is x to the 3rd. And then y squared. Can you leave it like that? No, that's silly, isn't it? Terrible idea. I'm pulling out a 3xy with 3x still chilling under the radical. Okay, and now it starts to get interesting, because it doesn't divide out evenly, right? You've got more k's in your denominator than your numerator here. This one's going to get a little bit more complicated, I think. But we can still do 243 divided by 3. 81. Good job by you guys. And that's going to be over k to the 4th. Well, this isn't too bad of a problem now. It's going to work out real nice for us, I think. Do you know the 4th root of 81? Three. And do you know the 4th root of k to the 4th? And so that's all we have to do is separate it as a numerator and denominator. And this one worked out real nice for us, which hopefully they all will. But I don't think we're going to be that lucky. Okay, so 18, we've got the cubed root of 18y squared over the cubed root of 18y. 18 divided by 12 doesn't work out evenly, does it? But we can reduce it. What does 18 over 12 reduce to? 3 over 2. We're dividing both the top and bottom by 6. You guys know your calculators do that for you? Is that worth looking at? I mean, I hope you guys can do that, but let's take a look at it anyway. Open. Sometimes it's voice activated. So we do 18 divided by 12. Go to math, change it to a fraction for me, and 3 over 2. Again, I expect you to know that, but it's good to know how to use your calculator too. So we have 3 over 2, and then we have y squared over y. So this is going to end up being the cubed root of 3y over cubed root of 2. All right, so here we go. This is today's lesson right here. It's all been fun and games until now. Now it gets serious. We can't have a radical in the denominator. Okay? So what I need to do is get 2 more 2's down here, right? Then I would have a group of 3 2's and it would simplify to a rational number. Y'all kind of looking at me like I'm talking some other language. Do you agree that this is equal to 2? Okay, that's all I need to know. That's what we need. We need a 2 down there. Now, whatever you do to the bottom, you have to do to the top. So I multiply by 2 2's up here as well. And I'm going to have the cubed root of 12y over 2. And I apologize, it's kind of tough to read. But that's the idea. We can't have a radical in the denominator. You're not allowed to ask me why. I have no idea why. And I have no idea when you're ever going to use this in your life if you're thinking something along those lines either. Probably shouldn't say that while I'm recording, but... I'm sorry? It does not simplify. You do have to try, but it would be 2 times 2 times 3 times y, and you wouldn't have any groups of 3 in there. So it doesn't. Right, you do have to try to simplify. It doesn't simplify, so we're okay. No, good question. Okay, would we divide 12 by 2? The answer is no, because this is under a radical and this is not. Okay, great questions, guys. That's awesome that you're thinking that way. So, understand what we're saying. This we can divide 54 divided by 2 because they're both under a radical. But here we cannot divide that because that's under a radical and that is not. Oh, good stuff. All right, so let's move on to 19. $162 divided by 6. I don't think that works. Does it work out evenly? Awesome, that's good stuff. Okay. So we would have square root of 27 over the square root of a squared. Good. Thank you for dividing that out for me. That helped. Okay, so square root of 27 simplifies, and so does the square root of a squared. And again, I bet a lot of you don't need to write all this out like this, do you? But here you're going to have a 3 radical 3 over a. Holy smokes, we got a lot left to do here, don't we? I don't think we're going to make it through everything. I'm sorry? Oh, was it? Oh, yeah, I skipped a step there, kind of, because I did the a over a to the third. I divided that out. That's how I got a squared. You with me? Okay, so on to number 20, 18 divided by 2. I like that. That works out evenly. I'm the square root of 9 x squared on the top and the square root of y squared on the bottom. All I'm doing is dividing these out. There's 9 x squared, and those are reduced to y squared in the bottom. This is going to work out. We don't have to break these down, do we? Do you know the square root of 9x squared? Do you know the square root of y squared? Okay. So if you want to break them down and you don't see that, I have no problem with it, but I'm hoping we're getting to the point where we kind of can see some of these and just come up with them. Okay, this one I think is going to be a little more interesting for us. Funny. Good one. All right, so I would see cubed root of, the only thing that's going to cancel is one of those x's, right? So 7y squared in the top and cubed root of 4x in the denominator. Yes, but let's start with the denominator. So if I want to break this down, I don't know if you have enough room, I'm going to erase this, and I'm going to write it as 2 times 2 times x. Now I can't have a radical in the denominator, so I need another 2 and 2 more x's, because we're looking for groups of 3, because it's cubed root. And now my denominator doesn't have a radical anymore, does it? The denominator is going to be 2x. So I have a group of 2's and I have a group of x's. Now whatever I multiplied by in the denominator, I need to multiply that in the numerator as well. And this is not a very nice problem because I still don't have any groups of 3. So my final answer is going to be the cubed root of 14 x squared y squared. Can I divide the 14 by 2? Exactly. Good job. So that's our answer right there. This will not simplify anymore, and that's a winner. Questions? '23, I think, is a little bit easier. We have the square root of 9x over square root of 2. Nothing canceled out. We can't divide it. We're not going to get anything. I can't have a radical in the denominator. What do I need to multiply this by? Simply a 2, right? And whatever I do on the bottom, I have to do the same thing on the top. And so that's going to be the square root of 18x over 2. But this simplifies, doesn't it? We can pull out a 3. It'll be 3 radical 2x over 2. Okay, we'll pick up with this tomorrow. Again, remember our homework is going to be on factoring. There are, 5 types of factoring. What are they? Greatest common factor. Trinomials. Grouping. Difference of squares. And perfect cubes. We did this one last night, so we're experts at that now. We're doing these tonight. Difference of squares and cubes. Okay? Now here's the trick on tonight's homework. You got to recognize what I'm looking for before you try factoring it. All right, so let's suppose I put x squared minus 9 up there. Are they perfect squares or perfect cubes? Perfect squares. They both have a square root. And so you say x plus 3, x minus 3. Okay, we could take the square root of x squared and we can take the square root of 9. We can't take the cube root of those. It doesn't work out evenly. Okay, suppose I had x cubed minus 8. Perfect squares or perfect cubes? Cubes. Do you remember this one now? Yep. Good. Okay, you recognize that as perfect cubes. It's going to look a little bit differently. How about that one? Do you know the square root of 8? Say no. Do you know the cubed root of 8? Yes. So these are perfect cubes, aren't they? Do you remember the pattern? Squared. Okay, so we want to think about cubed root of 8x to the 6, cubed root of 8, and then you divide that one. And then, of course, the cubed root of 1 is 1. So this is plus 1. What goes here? Or x to the 4th. Good job. Plus 1. Okay? So that's your worksheet. You're going to have to go through each one and recognize first, are they perfect squares? Are they perfect cubes? Let's do one more here. Squared, right? Good. And so this would be 11x to the 3rd plus 9, 11x to the 3rd minus 9.